Good morning, everyone, and thank you so much for joining us. So the other day you watched a video about classifying triangles where we outlined the definitions of these triangles in a graphic organizer. Well, now I'd like us to take a few minutes and look at some examples of each of these and apply what we learned earlier. So first of all, before we do anything else, I want you to have an understanding of something, because triangles all have three angles, and no matter what, triangles' angles, so triangle angles total 180 degrees. No matter what, no matter the triangle, all triangles' angles add up to no more than 180 degrees. And this is really important when we start talking about right triangles and obtuse triangles. So starting with acute triangles have all three angles are acute, meaning that they're all less than 90 degrees. And as you can see here, these two triangles have three acute angles. Okay, so acute triangles, all three are acute. All three are less than 90 degrees. Now let's take a look at a right triangle. A right triangle has one right angle. So that means that it equals 90 degrees. Now, here's the thing. I know in my mind, and I'm just going to use a sticky note here, if I have one right angle and I am trying to create a triangle, then that means if I do my third line and create another right angle, I can't create a triangle. It's not going to work. All right. Plus 180 minus 90 is 90. So if a triangle angles total 180 degrees every time, then you cannot have two 90-degree angles. It doesn't work. All right. Now let's look at obtuse angles, or obtuse triangles. I'm sorry. Obtuse triangles are triangles that have one obtuse angle. So one obtuse angle, which means that one angle is greater than 90 degrees, and two acute angles. That are less than 90 degrees. Now, for instance, if we look at our two triangles here in our example, I can automatically tell that this is an obtuse angle and that this is an obtuse angle. And remember, the angles in a triangle have to add up to 180 degrees. So if I have a triangle that has an obtuse angle of, let's say, 100 degrees, if the second angle and the third angle are added to that, it has to equal 180 degrees. That means that angles B and C cannot equal more than 80 degrees total. So that means that these two angles cannot be right angles. They cannot be obtuse angles. They have to be acute. So I'm going to label them in purple and I'm going to put an A next to them. Okay. And also we can look at it this way. If we have an obtuse angle, so there's an obtuse angle, let's say that it's 100 degrees, and we try and make another obtuse angle, that doesn't create a triangle. It can't, because a triangle only has 3 sides. So therefore, you cannot have more than one obtuse angle in a triangle. It will never, ever, ever work. So now let's move on to a scalene triangle. So a scalene triangle is a triangle with 3 unequal sides. So no equal sides. Three unequal sides. So in this case, we would have this one that's the shortest. And remember, when you are marking congruent and uncongruent lines, you are matching the number of slashes. So this side is 1 length, this side is another length, and this side is a 3rd length. None of them are equal. So each side is a different length. Okay. Now let's look at an isosceles triangle. An isosceles triangle. An isosceles triangle has at least 2 equal sides. Okay, so in this case, those 2 sides are equal, but the bottom edge is not. Okay. Now, this at least is going to be very, very important. Okay. So isosceles triangle has to have at least 2 sides that are equal. And I like to remember this because isosceles has 2 E's. So at least 2 that are equal. Okay. It's kind of a memory device that helps me. Now for an equilateral triangle, all 3 sides are congruent. Okay, they're equal. And we notate this with 1 slash through each. Now, here's the deal. If you remember back to these notes, we saw that an equilateral triangle is connected to isosceles. And this is where that at least 2 equal sides comes into play. Because an equilateral triangle is always an isosceles, but an isosceles is not always an equilateral. So an equilateral triangle can also be called an isosceles because an isosceles only needs at least 2 equal sides, minimum 2 equal sides. But an equilateral has to have all 3. So an equilateral is always an isosceles, but an isosceles is not always an equilateral. Okay. I hope that this has helped to clarify these definitions for you. If you have any questions or need any other support, please let me know. We'll see you next time, guys.